In the previous video, we have learnt as how we can create series using Pandas library. Now, let's look at how we can query the Pandas series. We can query the series by making use of either index position or the index label. To query the series using the numeric location starting at 0, we make use of iLock attribute, like this. Using the iLock attribute, I have queried the value at first index. Hence, it returned the value as 2. To query the series using the index label, we use the lock attribute. Let's say I want to query the same series and I want to find the value associated with index label C. So, I can make use of the lock attribute to query like this. I got the output as 3. Since the iLock and lock are attributes and not the method, we don't need to use the parentheses to query them. We just use the square brackets like this. Other special thing about Pandas is, even if I simply pass the index operator directly on the series like this, Python will behave as if we are using the iLock and lock attribute. But let's see what happens when we have the index as the list of numbers. To illustrate this, let me create the series like this. Now, let's try to query using the location. Let's say we want to query for the value at second position. So I'll pass as str_index 1 inside the square brackets like this. Once I execute the code, we are getting the error as key error. As we can see, the Pandas cannot determine automatically whether we are intending to query the series using the index position or the index label. So it's always recommended to opt for the safer, that is, to be more explicit and make use of iLock or lock attributes directly. So we are now clear with two concepts till now: creating the series and getting the data from series. Now let's understand about the next concept, that is, how we can work with data in the series. When I say work, a common task which we will be doing is considering all the values of data and do some operations involving it, isn't it? It is like trying to find certain number, summarizing the data or transforming the data in some way. A normal method which we know already from basics is iterating over all the items in the series and perform the operation which we are interested. To illustrate what I am saying, let's say we have a series like this. And if you want to find the sum of all the items in the series, then in our normal method, we would iterate over all the variables using a loop and finally printing the sum like this. Even though it looks fast, it's comparatively slow for a large number of values. The Pandas and the underlying NumPy libraries support a method of computation which is known as vectorization. This vectorization works with most of the functions in NumPy library. And we have already seen in the video of operations in NumPy while performing the sum. Just like we have computed for NumPy arrays, in the same way, we can write the code using the NumPy sum method. First, I'll import the NumPy as np. And then, we can simply call np.sum and pass an iterable item. In our case, it is Pandas series like this. So, we got the same answer. Okay, I know you have a question. Since both of them are giving exact same result, and how is that one method is faster than another? To answer your query, let me create a magic function in Jupyter Notebook to clear the doubt. First, let me create some large series of random numbers like this for testing purpose. I'll just use the head method to display the first 5 values of series like this. Now let's just verify the length of series using the len function. Okay, this series has 100,000 values. Let me now write a magic function. I'm now going to use the cellular magic function. It looks like this. It starts with 2 percentage signs and the function we are going to use is timeIt. What this function will do is the function will run our code few times to determine on an average how long it takes to execute it. First, let's run the timeIt using the original code, that is, by making use of for loop. For our testing, I have written the code to run the timeIt for 500 runs. Let me execute it. Okay, not bad. Just take a note of these timings. Now, let's perform the same actions using vectorization. Okay, I think the number clearly shows itself. As we can see, the difference in speed is very huge. Hence, I always suggest everyone who wants to be a better data scientist, then you should know the parallel computing features and start thinking in terms of functional programming terms. Now, let's look at broadcasting. With broadcasting, we can apply an operation to every value in the series. So, changing the series itself. To give you an example, let's say if I want to increase every value in the series by 3, then we directly apply like this to the series object. Before ending this video, I want to share one more thing. The .lock attribute lets us not only modify the data in place, but also add a new data as well. Let me print our existing series. So this is of int data type. Now, let's say I want to add a new index as A with the values hello to the same series. So I'll write a code like this. Once I execute the code, we can see that a new index A has been added with the value as hello. We also see that the data type has been changed to object. What this means is the pandas will automatically change the underlying NumPy types as appropriate. Apart from all these, in Pandas series, we can also have the index label with the same values like this. So, when we print it, we will display the entire list like this. In the next video, we are going to learn about Pandas 2-dimensional data structure, that is, data frame. See you then.